Let's take a look at this dentist problem. So how do we get the answers that were in the video? Real world problems are much more difficult, mostly because you have to translate this situation into an algebraic notation. So you have to take a situation that occurred in the real world and write it in algebra as an algebraic equation. And then actually do the algebra, do the arithmetic, do the computation to figure out the answer. And that's a lot of steps. And so we're looking at Dennis. He's buying frozen yogurt, or he works at the frozen yogurt stand. He's ordering boxes of small cups and large cups. So this would be like any kind of management position that you might have at McDonald's or Dairy Queen or whatever. You got to buy stuff. Got to buy supplies. And so the storage room can hold up to 10 more boxes. So at most it can hold 10 more boxes. You can't order 12 boxes, which means that everything is going to have to be less than 10 or equal to 10. One way or the other. Because at most 10. So you buy one box. That'd be less than 10. But up to 10 boxes of cups. And the only types of boxes we can buy would be the small cups or the large cups. And so I'm going to use X. I think I had X as being the small and Y as being the large boxes of cups. So the X, the small boxes, and the large boxes together have to be less than or equal to 10. Now we have some costs to worry about because, money. And so each box of small cups costs $100. So $100 for every box of small cups. Each box of large cups is $150. Okay? And we have a maximum of $1,200 to spend. You can't spend an infinite number of money because we just don't have it. And so the maximum we have to be $1,200, which means you have to spend less than that. So less than $1,200, because you actually do have $1,200 to spend, you could spend exactly $1,200. So it could be less than or equal to $1,200. Now we've translated this situation into a mathematical system of equations. Once we have that down, now we can solve it. And you can solve it by graphing. So to graph, we need to get y by itself. All right. For the top one here, it's not so bad. We can minus x from both sides, minus x from both sides. So the first one, we would have y is less than or equal to negative x plus 10, or 10 minus x, either one. But I'm gonna keep it in that mx plus b form. So that y equals mx plus b form. I'm going to put it in that form so I can graph it easier. The second one, which I'll keep in blue, the second one then is a little bit harder. We're going to subtract 100x from both sides, similarly to what we did a minute ago, 100x. We subtract 100x from both sides. So I would have, well, I guess I'm going to maybe do it over here. We'd have 150y is less than or equal to negative 100x plus 1200. So again, I'm solving for y. Divide everything by 150. There we go. And so I'm going to do 1200 divided by 150 and get 8. And I'm actually going to put it over here. So we have 8, 1200 divided by 150 is 8. Negative 100 divided by 150, I'm going to get, what was that, 2/3. So negative 2/3 x plus x. Now, if you do 100 divided by 150 and you get 0.66666666666 repeating, it's hard to graph 0.666 repeating. And so we're going to leave it as a fraction. Or I'm going to leave it as a fraction. Negative 2/3 x just makes it easier to solve, or to graph, excuse me. And then I'd have y by itself, and y would be less than or equal to negative 2/3 x plus 8. I've got my two equations written in a way that I can graph them. So now I'm going to graph. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I graph my blue equation, y-intercept is 8. Slope is negative 2/3 x. So I go down 2 over 3, down 2 over 3, down 2 over 3. There we go. It's less than or equal to. So it's going to be a solid line. There we go. And okay, I've got that, and it says y is less than. So I'm going to shade everything below the line. Okay, now I do my red one. So the y-intercept 10, the slope negative x, so negative 1, down 1 over 1, down 1 over 1, etc., 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 etc. Go. Okay. And it's less than or equal to, so a solid line, not a dashed line. And its y is less than, so I'm going to shade everything below the line. There we go. And, and I guess, yeah, there we go. And so the solutions, two possible solutions, are going to be basically anything in this area here, where it's both red and blue. You'll notice that I followed the blue line up at first up here, and then I started following the red line down here, because it's got to be both of them. And so where those two lines cross, that's going to be any possible solution. To be honest, I don't remember what solutions I gave on the main video, but you could pick any of them. You could pick this one, that'd be a solution. So it's 1, 2, so that'd be what, 3, 2. You could pick this one right here, which would be 5, 4. You could pick, let's see, 6. You could do 7, 2. You could do that point right there. Lots of possible answers that you can pick. You just have to list 2 of them. And that's how you would do this word problem.